A small fuel reservoir, or day tank, is needed to serve a power generator. Installing and maintaining this system is a complicated process. The first problem is that the generators require an atmospheric tank, meaning that overfilling is a potential hazard. The second problem is that the generator will not run very long without refilling, so this has to happen without fail.
Day tanks are usually sized between 50 and 1,000 gallons. The specific size is determined by A, the maximum volume of fuel that can be stored in the generator room based on fire code regulations, B, the space available in the generator room, and C, the user's perception of an adequate response time for facility personnel in the event of a day tank problem. Day tanks are UL-142 steel tanks. They typically have either double wall construction or containment rupture bases that may be between 110 to 160% capacity depending on local code. Day tanks may be horizontal cylindrical tanks, but are commonly rectangular for more efficient use of space in the generator room. They are usually incorporated into the base supports of generators, especially where the generators are located outside with prefabricated enclosures. The distance from the generator is usually a concern of the generator manufacturer. Cat engines are sometimes 50 to 100 feet from their day tanks, while Cummins engines typically require them to be adjacent. One consideration of a greater separation distance is that some local regulations may require that the day tank be separated from the generator to minimize hazards, and the day tanks be located in a separate, fireproof room. The day tank may be refilled by either suction pumps mounted on the day tank itself to draw fuel from a remote fuel tank, or remote-mounted pumps near the fuel supply tank with an inlet control valve at the day tank. The day tank is equipped with a level sensor to monitor fuel levels and control the refill. A common 5-point sensor would be 90% high level, 85% refill stop, 75% refill start, 50% low, and 15% critical low. The sensors provide inputs to a controller that operates the valves and pumps and monitors for failures indicated by high and low levels. Potential day tank failures should be provided with monitoring and redundant provisions. Common issues are A, inlet solenoid valve failure, backed up by a parallel solenoid valve, B, solenoid valve closed seal failure, backed up by a high stop solenoid valve, C, refill stop sensor failure, backed up by high level sensor, D, refill start sensor failure, backed up by low level sensor, E, control failure, backed up by remote monitoring and manual bypass method. Day tank accessory equipment commonly includes level and leak sensors, control panel, inlet solenoid valves, shut-off valves and strainers, normal vents, emergency vents, direct read gauge, inspection port, anti-siphon and fusible link on generator side, and generator inlet filters. Remote monitoring of the day tanks is often done by several systems for different purposes. The generator, switchgear, and building management system will typically monitor the day tank for high level, low level, and leak. The fuel system master controller will monitor for high, low, leak, fill start, fill stop, return flow pump run and fail, inlet valve position, and temperature. The primary protection against overflow is a gravity return flow pipe to the fuel supply tank. If the gravity overflow protection cannot be provided, like in the case of an above-ground tank, then an overflow pump needs to be provided and activated by the high-level sensor. Day tanks have both primary vents for normal breathing and emergency vents sized for fire conditions. The normal breathing vent is typically 2 inches in diameter and needs to be routed to the exterior of the building. The emergency vent device, typically 4 to 6 inches in diameter, is typically mounted directly onto the tank. However, some local fire codes require that the emergency vents be piped to the building exterior as well.